Okay. Part 5 is still part 5. Part 5 is property of Gij and Gij covariant, Gij contravariant. Now, part 11, lecture 11, expansion of A. Now, covariant components, not contravariant components of a second order tensor. You see, Tij, this is lower indices, okay? So this is called covariant component of a second order tensor. Then Ai, Aj, upper index, are the basis of this, you see, tensor product, okay? Now, this is a space, okay, vector space, this here. This is a dual vector space. You see, this is not vector space. Dual vector space. You see the star over here. So, then these are the covariant coordinates. Or this is called, let's call this original system. Original system, and this here is new, okay? New system. Just as we did the previous video, okay? Now, this tensor, second order tensor, is invariant. You see, invariant can be represented by these covariant components and the basis. You see. Now, this is a tensor product. In general, in the literature, we omit that. Okay. We omit that. You see, that's it. So, let's continue. You see how easy to relate this component with this component. It's very easy. You see, we will follow what we called attention on the previous video. You see, now, right here, basis, vectors, relationship, between the basis vector. Okay, let's mark here. That's by definition, A, P, A bar, P, by definition, is partial derivative of the position vector with respect to xp. See, look how I called attention. This is free, this is free. So this one, you see, is contravariant. This one is also contravariant because the P is lower, okay, in the denominator. See, just for you to understand. So I can, using the chain rule, this is equal. Look how easy, okay? Look, this is P. You see the chain rule, okay? I'm sorry, let's put the P over here. Now, the chain rule. Now I will do the same. That's C, I, C, I. You see, I is dummy. Attention now. I is dummy. P, you see, P is free. You see, in the lower indices. This, by definition, this is A, I, partial of C, I, partial of C bar P. You see, this over here, you see, by definition, this is AI. Now, attention now. I over here is dummy. But individually, if you look at I, okay, here, and look at I over here. I is contravariant. Ci is contravariant because I is lower index in the denominator. It's quite clear, see? Though, so I have a relation between AP and AI. Now, I'll do the same for AQ, see? AQ is by definition partial of R with respect to CQ. You see, I forgot here this bar, okay? I forgot this bar, okay? But the bar is over here. Because this one is the red one. I just use the same color. Again, the chain rule, partial of R, partial of CQ. Bar. See? Now, I'll write partial of CJ, partial of CJ. Again, J is dummy. Q is free. Look at the left hand side. Q is free. This is contravariant. This is contravariant. Why? Because lower index in the denominator behaves like contravariant. That's just clear. And this one, by definition, is A J. See? So I can write here, this is, I'll put first, okay? This one, J, K, AJ. You see, quite clear, this AJ over here. Now I can do as follows. Oh, see, look how easy, okay? A, P, attention now, tensor product here, I will omit this, okay? A, Q. I'll just substitute these two over here. So this will be, I'll write first this one, okay? You see here, A, P, A, Q, A, P, A, Q. I just copy from here to here. CI, I'm sorry, there's a lower index, partial of CP, AI, I'll put AI over here. AI. Now, I'll copy from this here to here because it's AQ. So, partial psi J, partial bar Q. AJ. So, you see, this is Jacobian. This is in R3, this is a 3 by 3 matrix. So I is lower indices. And P, attention, P behaves, okay, as contravariant. So P comes here. And I comes here. See? This one. This one, the same, this J. Now, this is Q. Q behaves as a contravariant. So this Q come here, and this J come here. Quite easy. You see, it's easy. You see, easy. Now, I'll write A, I, AJ. I'll continue, okay? So this is a relationship between AP, AQ with AI, AJ. Basis, contravariant. Why? Because they belong to the dual. Okay, attention now, okay? Coordinates are contravariant because coordinates here, basis is contravariant. Components are covariant. Okay? Why? Because they belong to this tensor product, dual tensor product. Okay? That's it.